Section 3.4 Mesh Analysis. Before we learn this method, we should know the concept of mesh. A mesh is a loop which does not contain any other loops within it. And the mesh analysis applies KVL to find unknown currents. And the mesh analysis can be only applied to a circuit that in a planar or for a planar circuit. A planar circuit means there is no crossing branches within it. For example, the circuit in graph A, and we can find crossing branch, but actually it is a planar circuit because we can redraw the circuit as the graph B. So in graph B, we find there is no crossing branches. So it is a planar circuit. That means the mesh analysis cannot be used for a space circuit. Okay, now the steps to determine mesh currents. Step 1. Assign mesh currents I1, I2, and so on until IN to the n meshes. Step 2. Apply KVL to each of the n meshes. Use Ohm's law to express the voltages in terms of the mesh currents. Step 3. Solve the resulting n simultaneously equations to get the mesh currents. And we're going to use this example to represent the steps of mesh analysis. For these circuits, there are only two meshes, and we're going to assign the mesh current I1 and I2. Both of the mesh currents are clockwise. So we should know the capital I1 equals the mesh current I1, and the branch current I2 equals the mesh current I2. But the branch current I3 equals mesh current I1 minus mesh current I2. And we apply KVL to mesh 1, and we get this equation R1 plus R3 multiplied by I1 minus R3 multiplied by I2 equals V1, where V1 is the voltage of the voltage source in the first loop. For the mesh 2, applying KVL gives minus R3 multiplied by I1 plus R2 plus R3 multiplied by I2 equals minus V2, where V2 is the voltage of the voltage source in the second mesh. And now we have two equations, and we have two unknown variables, which are mesh current I1 and I2. And of course, we can solve the equations, and then we can get I1 and I2, and we can calculate all the branch currents. In this case, we choose both of the mesh currents direction as clockwise, but actually the direction of the mesh current is arbitrary. That means you can choose clockwise or counterclockwise, and it does not affect the validity of the solutions. That means no matter which direction you choose, you will get the same solution. This is the end of this section.